Alright, so the first couple of examples in this video. So suppose that we have a seat assignment. So in a large lecture room, there's a seat assignments. So the seat assignments consists of a letter, followed by a number. Letters are always our alphabetical letters A to Z, and there are 26 letters total. Followed by a number. Numbers are 0 to 9 unless told otherwise. Because of 0, that means we have 10 numbers. Right? Because numbers 0 to 9, 0 would count as the 10th number. Right. Assume that you can repeat unless told otherwise. So if it says you can't repeat, it's the only time you can't. Otherwise, we assume that we do, because we assume that we have the most. We always want to include the most possible outcomes in our cases. Alright, so again, we're counting. Count means that's how many. That's the count. Not probability. Count is how many. Number of. Alright, so how many total seats? So this would be the big set, the total set. How many total different seats? Well, we have a letter and a number. Right? We have a seat assigned with a letter and a number. So letters, there's 26 of those, and we multiply. There are 10 numbers. And so there are 260 seats. Right? Because every A would have 10, every B would have 10, every C would have 10, all the way on to Z, there'd be 10, right? Because we have A 0 to 9, B 0 to 9, and so on. So it should make sense that that's the case. All right, suppose that your favorite seat is A6. Find the probability that if you're randomly assigned a seat in class, that you will get your favorite seat. Well, this is just one outcome, right? That's it. There is only one seat that is A6. And so probability, remember, is the event divided by the total. The event is there's one seat that's labeled A6 out of my 260 seats. So that's the probability that you get that one seat. Alright, and I'm just going to leave it 1 out of 126. You can find the decimal on your own, but most of the time these would we leave it exact. So I'm going to leave it exact. Alright, find the, so that's the probability. Remember, probability is then we do the division. So when it asks for probability, when you do the division, when it asks for how many, you count. You just do the count. Alright, find the probability again. So I'm looking for probability of the event divided by my total. I'm not. So this is the complementary event. This is the not case. So probability that we have not my favorite seat, not A6, is 1 minus the probability you do get A6, which we found in the last example, right? 1 minus that probability was 1 out of 260, which, if you think about it, that means there's 259 desks that you could get because we're not giving you A6. Alright, and that one you can leave. I don't think it reduces, so I'm just going to write it as again, pretty high probability. 0.996 or 996% chance that you will not get your favorite seat, which means there was a, figure this one out, 0.004% that you did. Alright, I'm going to do the next example. So I'm going to do the first two examples in this set of notes. Alright, so we have a 4-letter code from the letters in the English alphabet. Assume that you can have repeating letters unless told otherwise. So again, unless you're told otherwise, assume you have repeating letters. How many different codes can be created? So codes, meaning, right, when you type in, like, suppose you did a PIN number on your phone, right? You have a code on your phone. You have to type it in the correct order. Alright, so in this case, we have a 4-letter code. And so from the English alphabet, remember there are 26 letters total. So we have to pick, and I'm just going to write it out. A lot of times when we do the codes and numbers, we'll do a little dashed line because it's always and. Right? We have the first letter and the second letter and the third letter and the fourth. Alright, since we already know we're going to have to pick 4, it's always the and, right? I pick the first and the second and the third and the fourth. Well, since we're allowed repeats for every single one of these picks, there are 26 possible letters I can choose from. Right? 26 for each of them. So 26 times itself, which you can shorthand to 26 to the 4th, or I'm going to actually find that number. It's a fairly large number. All right, it's 456,976 total codes. All right, that would be the big set. How many, so again, we're counting, so we make sure we know this is just the count, not the probability. How many of the almost 500,000 codes only use the vowels? So this time, when I'm setting up my code, instead of picking from all of the letters, we're only picking, so this would be my first vowel, the second vowel, the third vowel, and the fourth vowel. So it's all and. I'm going to pick my first vowel, and my second, and my third, and my fourth. And so we only pick from those 5 letters. So there's only 5 for the first one, then we get to repeat. So there's 5 for the second, 5 for the third, and 5 for the fourth. And so that would be 5 times itself 4 times, or 625 of those. So 625 codes with only vowels out of the total. So if we found the probability of that, it would that number divide by the total. We didn't find probability, we're just counting. We're just count. And I'm going to take my arrow away. Now we're going to find a probability. Alright, find a probability. Which means probability, which is my event over my total. So I'm going to find my event and divide by that big number that's my total, that 26 to the 4th. Alright, a randomly selected code ends in a vowel. So I'm going to do my event first. Event number. So we've got our 4 letters. This is a vowel. Alright, ends in a vowel. Doesn't say anything about the rest of them, so the rest of them can be anything I want, vowels or consonants. So for the first 3, I've got 26 for all 3 of those. Right? Because I can pick anything I want for the first 3. The only one that matters is the last one. The last one has to be a vowel, and we're going to assume the A, E, I, O, U are my vowels. And so the last one only had 5. 5 options that I can choose. And it's and for all of them, right? I picked the first letter and the second and the third and then a vowel. And so we multiply that out, so it'd be 26 cubed times 5, and again it comes out to a fairly large number. That would be how many of the codes end in a vowel out of my total. And so when we want to find the probability, you take that 87880 divided by the total, which would be the 456,976. And right out, it does reduce down to 5 over 26, or 0.192, 19.2% chance. All right. How many? So again, we're just counting. When you read the problem carefully. Are they asking you probability, or are they asking you just to count? How many codes do not contain any repeated letters? So now we're no longer going to repeat. No repeats. So once a letter is selected, you can't select it again. And so we're going to pick our 4 letters again, but we cannot repeat. It's kind of like when we do the M&M example. I pull out an M&M and I eat it. Same thing here. I choose a letter, and you can't choose it again. So if I choose the letter M, it can't be picked again. So the next letter, there's only 25 left over because I picked M. So the first one, there's still 26, but the second one, this is where we do the subtraction. There's only 25 left for the second. We've picked 2 now. Means there's only 24 for the third, and 23 for the last. So every single time you make a selection, a letter, there are no repeats, so you have to subtract each time. Right. And then it's a multiplication, because you're going to pick the first letter and the second and the third and the fourth, so multiply that out. It comes out to 35880 possible outcomes with no repeats. And then the last one, find probability. So now we're finding probability, so it's my event over my total. So this one we're going to do a division. I'm going to do the probability. that the randomly selected code does not contain, so it's the previous answer, probability of the event, which was 35880 over my total. My total was that big number, 456976. 456976. Doesn't reduce real nice. That's the smallest fraction it goes. Again, you have the fraction key on the calculator. You can just hit divide and then hit your fraction. Alright, so 0.785. So 78.5% chance you get a code with no repeating letters. I'm going to stop there and pick up the next example in the next video so I can keep these videos short.